We are doing calculus revision, and in particular we're going to do D operators. So we will do two examples in this video in preparation for the exams. The first one where we're going to do the shift rule, and then the second one where we're going to find the general solution of a D operator without the shift rule. So let's get straight on to the question. So they will ask you in exam to find the general solution of your differential equation, which is in terms of a D operator. Remember, D represents d over dt. So they ask you to find the general solution. Now just recall that the general solution is the complementary function plus the particular solution. Now, our D operator is always in this form. It is our polynomial in terms of D times Y. Then we have our function A in terms of T, and we have e to the beta t. So in our question, what do we see? There's our polynomial in terms of D. There is our at, because it's our polynomial in terms of t, and we have e to the t. But now, as you can recall, when you do the complementary function, you will let your D operator be equal to 0. What will we do then? We are going to solve d plus 1, d squared plus 1 is 0. So what do you recall from complex numbers? D squared plus 1 is 0. So d squared is minus 1. But you know minus 1 is I squared. Hence d is plus or minus I. So for this factor you have d is plus or minus I. For this factor you have negative 1. Now as you can recall from D operators, very important, if you only have one factor, you will have in your complementary function, you will have ae to the alpha t. So, hence what I've done here, since I just had d equals negative 1, just that one factor, I have my parameter c1, then I have e to the negative t. But now, when you have complex roots, so just recall, when you have complex roots, you will look at your root a plus bi. So you will always use the one with a positive b. What do you see here? You have positive I, and you have a is 0. So you have 0 plus I. Then always remember, for the complex roots, your complementary function will be e to the at p cos bt plus q sine bt. So that's what we always use when we get the complementary function for complex roots. Now, sometimes you could, or you can also use this. I'm sure the lecturers mention it, but I prefer to use this for my complementary function when I have complex roots. Hence here, since my a is 0, I have e to the 0t, and since my b is 1, the coefficient of I have p cos t plus q sine t. And there I've done my complementary function. Now, that was my complementary function, so we should in exams just say, indicate that we're doing the complementary function. Now the next step that we're going to do, we are going to find the particular solution. Now what I'm going to say now is extremely important for the exams. So remember I said that your D operator will be in this form. Now what I want you to remember, if at, so my polynomial in t is a constant, hence just a value a real number, and it is and P of beta is not 0, you can just write down this solution. This will do in our second example. But in our first example, we will see that our polynomial in T is not a constant, so not just a numerical value, or it's not and, it's or. If P of beta is 0, we will always do the shift rule. Hence, in our example, when we do the particular integral, since our AT, there we have, remember it's in this form, there we have our polynomial in T. Hence, AT is not just a numerical value, it's not just a constant, so we will execute the shift rule. Now just remember here, since we're saying it's in this form, our beta, in my case, it's a coefficient of T always, is 1. Now this is what we're always going to do when we do the shift rule. Just a reminder that you can also watch my videos on D operators. There were 2 videos in the playlist if you need more practice. What I'm going to do now, so what you see here, since I'm doing the shift rule, I have e to the beta t. Now I'm going to do 1 over b d plus beta. But what do I have in my case in the numerator? I will have 1 over b d plus 1. Why d plus 1? Since my beta is 1. Now often students will make a mistake here. They will take the 1 across and they will say beta is negative 1. No, you will just use beta as 1. Hence, you have your polynomial at d plus b, in our case d plus 1. What does that mean? I'm going to replace d with d plus 1. So what do I get? I will get d plus 1 plus 1. I'm going to replace d with d plus 1. So d plus 1 squared plus 1. So that is very important. Now a very important thing, when you get here, you always have to simplify. So you have to distribute the 2 brackets in. So I have d plus 2, this bracket of d squared plus 2d plus 1 plus 2. So like I always say in my videos, it is advisable that you pause here and you do the steps by yourself. You continue with the video and just compare it to my working. But now I will always simplify this. So I will always distribute in. So if I distribute in, that's basic maths. I'm not going to do all the steps. You are going to end up getting that. So you're welcome now to pause the video and just make sure that you get that answer. But now a very important thing. We want to write this. We want to use the binomial expansion to write it as a polynomial. Hence, what am I going to do? I must get either of these 2. I must either get 1 plus a u, I will tell you now what I mean by u, to the power of negative 1, or I must get this. So very, very important that you must always get the 1 and you expand using the binomial expansion. So if it's 1 plus u to the negative 1, you will alternate 1 minus u plus u squared minus u cubed and so on. If it is minus u, you will just have pluses everywhere. So let's see what I mean by that. So I really want you to study this for exam. Just make 100% sure you're familiar with that. So what do I see here? What I've just said. you have to use the binomial expansion, since that is 1 plus 3 over 2d plus d squared plus d cubed over 4 to the power of negative 1. And hence the reason why I need these, why I'm going to use one of these two, just to understand where I got that from. So remember, you need a 1 there, so I've taken out 4 as a common factor. So I have 1. If I divide there by 4, 6 over 4 is 3 over 2. Always simplify in maths. And then 4 divided by 4 is 1d squared, and then d cubed divided by 4. Now look what I'm doing. I am going to let my 3 over 2d plus d squared plus d cubed, I'm going to let that be u. Why? So that I can get the form 1 plus u to the negative 1. So 1 plus u to the negative 1. Why do I do that? So that I can use the binomial expansion. Now I'm going to say a very important thing, because how do you know where to stop since it's a binomial expansion? You will always expand to the same degree of what you're acting on. So if you're acting on t, that's why I've just stopped at u. However, if you, for instance, acting on t cubed, you will expand to the third power, but it's important that you do put plus dot 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 to indicate that you know that you can continue. I will explain it just now as we continue with the example. So that is very important, because often students fail to remember that they just have to expand to the same degree as the polynomial they're acting on. Now you'll see why it is. Now I put u back. Now just recall u is this, and if I times u by negative 1, hence all my terms are negative. And don't forget the dots to indicate that you know that you can expand further. But now you'll see why we do it. Remember, we're acting on t now, so 1 times 1 and t is just t. If I act with this term on t, remember what we said earlier, d is the derivative of t, which is just 1 times minus 3 over 2 minus 3 over 2. If I derive t twice, derive once, I get 1, derive twice, I get 0. D cubed, derive once, 1, and then all the derivatives will be 0. Hence why I could stop at u. So what is my final answer for my particular? There is my answer for my particular solution. Now just recall, you want y complementary plus y particular. We've just done y particular. Just now we did the complementary function, which gave us this answer. Now I just put them together, and there is my final solution. So the next question we're going to do, find the general solution of this D operator. Now recall what I've just said. When you do the complementary function, because remember, if they ask for general solution, you must solve y. So you must solve your complementary and your particular. So complementary equal to 0. So now I'm going to factorize this. Now just if you've watched all my videos, especially on complex numbers, you will know that when I get a quadratic, I will quickly check whether or not my roots are complex. So I do b squared minus 4ac. B squared is 60 minus 4ac is 6. I have 16 minus 24, which is minus 8, which is less than 0. And less than 0, b squared minus 4ac less than 0 means complex roots. Now, again, for complex roots, I'm going to use this. It is advisable to just use that. How do we get that? We always complete the square. Now, since we've done completing the square a lot in my videos, I'm not going to go through the steps. You can pause again and you can make 100% sure if you also, and just make sure if you get the same as what I got here. So what does it mean? My A is -2. So often students fail to use the -2. Remember, it's d plus 2 is 0, so A is -2. And then students often make a mistake here as well. Remember, b squared is 2, hence b root 2. What do I have here? Remember, this is my solution for complex roots or complementary function. I have e to the -2t because root 2t plus q sine root t. So onto the particular solution it is. Now, very important, remember what I've said just now. Your D operator is always in this form. What do you see now? Your beta is coefficient of t. So my beta is -2. What do you see your 80 is? We have times 1 here. Recall what I said earlier. If your 80 is constant, but remember we had an AND condition. So if 80 is constant and, it's very important, P of beta is not 0, because now remember, you are going to write your solution like this. So P of beta is in the denominator, so it cannot be 0. Now, if you have these two conditions, that AT is constant and P beta is not 0, you can go to your solution straight away. Please remember that. Do not waste time with the shift rule. So you have e to the -2t. Recall AT is just a constant 1. P beta. So you're going to replace your polynomial in d. You're going to replace d with beta. Beta is -2. Hence, -2 squared plus 4 times -2 plus 6. So you have 2 at the bottom. You are safe because you do not have 0. And there, that was quite quick. There is our particular solution. So this one without the shift rule is very quick. So what is your general solution of your differential equation? It's your complementary plus particular. Just now we got the complementary. Here we got your particular. And there you have your final answer. So this is the end of the exam revision on D operators. Please just look out for my other videos on exam revision topics.